It's time for Security Now. Steve Gibson is here. We're going to talk about Patch Tuesday, 55 flaws. Steve will break it down. There's a security issue in a piece of security hardware you're going to want to know about. And then the latest version of Rowhammer. It's called Blacksmith, and it affects all DRAM everywhere. It's all coming on, boy. It's coming up next on Security Now.
Podcasts you love.
From people you trust.
This is TWiT.
This is Security Now with Steve Gibson, episode 845, recorded Tuesday, November 16th, 2021. Blacksmith. Security Now is brought to you by Thinkst Canary. Detect attackers on your network while avoiding irritating false alarms. Get the alerts that matter. For 10% off and a 60-day money-back guarantee, go to canary.tools/twit and enter the code TWiT in the How Did You Hear About Us box. And by ExpressVPN. Going online without ExpressVPN is like using the bathroom and not closing the door. Secure your online activity by visiting expressvpn.com/securitynow and get an extra 3 months free on a 1-year package. And by Stripe. Whether you're an online or in-person retailer, software platform, marketplace, or subscriptions business like ours, visit stripe.com to learn more about how Stripe can support your business today. It's time for Security Now, the show where we protect you and your loved ones in the vast online world of cyberspace with this guy right here. He's been around since before cyberspace began. What are you doing? Steve Gibson.
All is blowing up, Leo.
It's blowing up.
Just kaboom. Yes.
Security Now time. I know you wait for this all week long. So do I. Here we are. Hello, Steve.
Well, hello, Leo. Hello.
Hello.
So we have actually the topic I was going to discuss got bumped to next week. I was going to talk about something called HTTP request smuggling, which it turns out has been a known problem for a while, but it's only just become like abused. So I thought, oh, that'll be fun to talk about. But then yesterday, a paper dropped from some guys at ComSec, who are the guys at ZTH, I want to say Zurich, but that's not right.
Zurich.
Zurich. Hello. Yes. Zurich. The security guys who've done, we've referred to them a bunch through the years. They've taken Rowhammer, the original DRAM Rowhammer problem, way further. And it's not good. So I thought, okay, that's more important than a problem which has just come into fashion, apparently. So we have a lot of things to talk about. We're going to look at a critical 9.8 rated vulnerability affecting Palo Alto Networks' widely developed VPN firewall appliance, and at a welcome new micropatch from those zero patch guys. And the nature of it leads me into a bit of a philosophical musing about the Zen of coding, which had me thinking of you because I know that, and also a little bit about chess and your affection for that. But anyway, we'll get there.
Boy, my two favorite subjects. I can't wait.
Then we're rocketed back to reality by a review of last week's Patch Tuesday, looking at what it broke and, happily, what more it fixed, including hints that Christmas might finally be coming to printing by December. But not yet, children. We have some more encouraging ransomware versus the law news, where the law apparently is winning. And we examine the question of how to make big money defrauding online advertisers. Then I'll share some fun and interesting closing loop feedback from our listeners. And boy, we got some neat listeners. A brief update on my SpinRite work. And then we're going to take a look at Blacksmith, which is the evolution, probably the ultimate evolution of Rowhammer attacks on DRAM and the fact that nothing can be done.
Oh, no.
It's one of those happy endings.
And I hope you'll do a refresher on what rowhammer is. And
I've got that in the notes.
Yeah.
Yep, for sure.
Because there's so many things, and, we forget.
And then we do have, for those of us who have, well, not thus, I'm no longer among them, but maybe Elaine, who, she uses a satellite link last time I checked, and her connection is slow, which is why she originally asked me if I could recompress these from your beautiful sounding 64 kilobits down to 16 to conserve her bandwidth. Well, there is a solution, it turns out, Leo, for people with highly constrained bandwidths who wish to install Windows 11. And we've got the picture of the week to demonstrate that.
Okay. No hints, no clues, but that's good. That's coming up. I want to talk about this. You were the guy who got me all excited about honeypots way back when. I think episode 2 of Security Now. And then we talked to Bill Cheswick, who wrote the very first honeypot. He was out with us in Boston.
I can see the lights on.
Oh, yeah, this is working. This is a honeypot.
Actually plugged in.
Yeah, of course. I keep my honeypot plugged in. What would I do without it? This is a Thinkst Canary, and this is actually the best honeypot money can buy because it's simple to set up. It really is just an appliance, but, man, this thing is brilliant. They have put a lot of thought into this. The folks behind the Thinkst Canary actually were specialists in this. They've been in the security game for more than 2 decades. They've trained companies, militaries, and governments in how to break into networks. See, these guys are experts in that. So they built the Canary to help defend you against the guys who break in to networks. This is a big problem, the advanced persistent threat. The bad guy who gets into your network, whether it's through an exploit or phishing or whatever, but somehow gets in your network, and instead of immediately triggering destruction, that's the easy thing to do. Nowadays, what they do is they examine every bit of your network. They wander around. They look at things. They look at how you're doing backups, for instance, because they want to make sure they blow those up as well. They maybe will start exfiltrating private company information. That's what they did at Sony. That's what they did at Starwood Group. The hackers at the Starwood Group, now Marriott, were in there literally, I think, 4 or 5 years. The Sony hackers in there, I think, 8 months before anybody noticed. In fact, they didn't notice. They never noticed. They only found out when the breach was announced, the ransomware triggered, and there you go. These canaries are the answer to that. They are going to sit on your network, and they're not going to look like some vulnerable piece of gear. They're going to actually look like something real and something valuable. This one, for instance, is configured as a Synology NAS. And when I say configured, it was easy for me to do. I used the web console, very simple, but it actually gave it a MAC address that's the same as a Synology NAS would have. It has the Synology, code at the beginning. They gave it a login page that looks identical to DSM. The Synology software. So anybody seeing this, looking at it, pinging it, examining it, even the most suspicious hacker will say, yeah, that's a NAS, and I want to get into it. And, of course, the minute they do, you get an alert. Actionable alerts, not a bunch of false positives, but actionable alerts that are triggered by somebody in the network doing something they shouldn't do. The Canary can also make tokens. We talked about that years ago when they first announced it. Generate files, PDFs, docs, spreadsheets that you can scatter over your network. They look just like the real thing, but as soon as somebody tries to open them, boom, it talks to the Canary, which is inside your network, so it looks like normal traffic, and they notify you. You can have your alerts by email, by text. You get a console with your canaries, Slack, webhooks, syslog if you use that, and even have an API so you could write your own software to do this. They're great. You could put fake files on them. You can enroll them in Active Directory. The philosophy of Thinkst and the Canary is trivial to deploy with a ridiculously high quality of signal. You get an alert, but no false positives, just alerts when it's really important. It takes the average of 191 days for a company to realize there's been a data breach. That is way too long. Thinkst Canary solves that problem. And I think it's super reasonably priced. If you wanted, some companies have a handful of them, big banks, others have many, many more. They're deployed all over the world, all 7 continents. So that gives you some idea. I mean, the governments use them, businesses use them. Let's say you wanted 5, for a relatively small, simple network, $7,500 a year. You get 5 canaries, but you also get your hosted console that I mentioned. You get the upgrades. Sit on it. They'll send you a new one. No questions asked. So support. You get maintenance. And all you have to do is use the code TWiT in the How Did You Hear About Us box. You'll get 10% off, not just for the first year, but forever, for as long as you're a Canary customer. And we know you're going to love this thing. I mean, it's just really amazing. But if you're not happy, they do have a very generous 2-month money-back guarantee for a full refund. 2 months. So you have plenty of time to try it. The funny thing is, and I should warn you, as long as no one's in your network, this is silent. You don't hear a thing. But when somebody is, you hear about it. We have only been triggered once, and that was when somebody put a scanning NAS system on our interior network, and it was scanning every IP address. It was like, we don't know why, but we immediately figured out who it was thanks to the Canary and disabled it. Thinkst, THINKST, but the website is canary.tools/twit. If you go to canary.tools/love, you'll see all the people who swear by the Canary and all the hackers who swear at it. Thinkst Canary, canary.tools/twit, offer code TWIT. Put that in the How Did You Hear About Us box for 10% off. Thank you, Canary, for supporting Security Now. We think it's a very good partnership. They've been with us for quite a few years now, and we've sold quite a few of these, and everybody's very, very happy. It's a great device. Canary.tools/twit. Ready for the picture of the week? You have this picture practically.
Yeah. So someone tweeted this to me, and it just caught me at the right moment. It was kind of funny because those old timers among us recall when you did install Windows, like 3.1, came on a deck of 3.5-inch floppy disks.
Show them your 8-inch Windows 1.
So I actually just turned.
Look at that.
It just occurred to me to pull those out of a drawer. They weren't even giving it a version number at that point because it was just called Windows.
Wow.
And of course, it used to run on DOS, so it wasn't its own operating system. So the label says Windows Standalone Runtime System, Setup Disk 1 of 2, and Utilities Disk 2 of 2, copyright 1984 and 1985.
Nice.
So
just to bring us up to the present, though.
Yes, I was going to say, since then, Leo, there's been a little, I don't want to say bloat, maybe I do. We now have Windows 11 available on 3.5-inch disks. This shows 2 of them of 3,852.
Did you do the math to see if that's accurate? I bet that's low.
Actually, in my head, it's about right because you figure one of those is 1.44 megs.
Yeah.
So 1.44 megabytes times 3,852, that's going to bring you to around the, 5 gig or so, which is right, where Windows 11 is now. Now, of course, it was always a problem back when we were installing Windows from 3.5-inch floppies, is that, you'd get it about to the 4th disk and it would go, and it you'd have a read problem. And
I remember those days.
You eject it and put it back in again and hope that you'd get a better settling of the hub, which was metal on these. The track density of these was high enough that you couldn't use just a standard Mylar hole. So they had metal hubs in order to get better centering. But even so, and it's like, oh crap. Now, given that installing Windows 11 this way would require 3,852 of these, I would say your chances of actually getting Windows 11 running are about the same as they are today when you download it and and run it. It's like, good luck. Anyway, just a fun picture of the week, and thank you to whomever thought to send it. I appreciate that.
That's so true, too. Gosh, thousands.
Yeah. Okay, so around 10,000 VPN firewall appliances from Palo Alto Networks are vulnerable. And once again, actually, I don't blame the tech press for calling it a 0-day because the guys who found it called it a 0-day in their announcement. So the tech press, who is, just taking their copy from the announcement, parroted that, right? They're calling it a 0-day. Nothing about it is a 0-day, but it's definitely a very serious vulnerability with a vulnerability severity score of 9.8. And as we know, we're still waiting for a 9.9 or a 10. I don't know what that even looks like because everyone seems to hit the ceiling at 9.8. But this is as bad as it gets, 9.8. It affects, as I said, Palo Alto Networks. The product is the Global Protect Firewall, which allows unauthenticated remote control, remote code execution on multiple versions of their PAN OS from family version 8.1 prior to 8.1.17. So that's where they fixed it in 17. If you've got 8.1 less than 17, you're in trouble. And this affects both their physical and virtual firewalls. The discovery was made by a group we've never referred to before, known as Randori, R-A-N-D-O-R-I, and their site is randori.com. Their disclosure, which, as I said, also sadly labeled this as a 0-day. They wrote, the Randori attack team developed a reliable working exploit and leveraged the capability as part of Randori's continuous and automated Red Team platform. Our team was able to gain a shell on the affected target, access sensitive configuration data, extract credentials, and more. Once an attacker has control over the firewall, they'll have visibility into the internal network and can proceed to move laterally. And of course, this is a problem because there are 10,000 of these things out there, all vulnerable until they're patched, and we know how that goes. And, no mom and pop is gonna. I don't have one of these Palo Alto Networks firewalls. I've got a nice little PF Sense system here. The point is that these are going to be, serious enterprises that are using these Palo Alto Global Protect VPN firewalls, so they're going to be a hot target for guys who want to get in and get up to some mischief, moving laterally to do their nefarious ransomware stuff. So in an effort to avoid enabling misuse, technical details related to this, it's been given a CVE number 2021-3064, will be withheld, they write, from public dissemination for a period of 30 days from the date of this publication. And again, that's why it's not a 0-day. I mean, it's not in the wild. It wasn't discovered being used. It's a vulnerability. So, okay, good that we found out about it. They responsibly disclosed this to Palo Alto Networks, who quickly said, after recovering from their unhappiness, updated this 8.1.16 to 8.1.17, fixing the problem. I'm sure they sent out announcements to anyone they had access to, hopefully stressing the importance of updating the appliance.
So this is kind of a security success story. I mean, nothing's perfect. You're going to have flaws. You wish you wouldn't.
Yes. And as always, it's that last mile is the problem, right? It's a security success story until we start covering the disasters which ensue when people don't patch, when they don't, for whatever reason, communication failure, lack of resources, the IT security guys are too busy putting out other fires. The enterprise hired a consultant. I hope they have somebody full-time on staff, because that's now required these days. But what will happen is more than half of these will not get updated. And Rodan has found them all. These have been indexed, so the bad guys can immediately target them, use this unpatched versions to exploit them, and then crawl in. So, yes, it's a success story all the way, as I said, Leo, to like that last mile, which requires that people get these things kept current. And
Shodan.
it's
Shodan, not Rodan. Shodan.
Oh, right.
I understand where Rodan came from, because that's kind of the sort of like the people who discovered this. So that's what confused me at first.
Right, Randori.
Yeah, Randori. Yeah.
So anyway, this question of should things update themselves autonomously. We're now, the machines that we have in our pocket, they do that. Windows has continued to push that further. They have their monthly patch cycles, but now they've started doing this other new thing, because that's not in some cases often enough. So they're able to update their Windows Defender patterns at any time they want to, and so block things that are coming in before Windows has had a chance to be strengthened against them. So, the fact is, we're seeing this model evolve where updates are being delivered autonomously. And it seems that there's still pushback. When I talk about this for consumer routers, I get, not hate mail, but people saying, to think of what happens if a mistake is made. And it's like, well, yeah, but, is that worse than, a serious vulnerability being left unpatched by the bulk of the population? Consider what the chances are of a consumer router ever being updated. I mean, our listeners, yeah, pretty much more than that? Probably not. Anyway, the vulnerability chain consists of a method for bypassing validations made by an external web server, and that's where this term HTTP smuggling comes in. This is actually an HTTP request smuggling attack, which we will be covering in detail next week. We've never talked about it, and it's interesting. And obviously, here's an example of a really bad problem being impacted that way. The good news is the Randori guys are acting responsibly. They're keeping the details to themselves. I'm sure they'll come out with full details in a month. In the meantime, boy, if you or anyone you know is using a Palo Alto Networks VPN gateway, make sure that you're patched. The Zero Patch guys, who I think have found themselves a niche in the world, have produced a Micropatch. Recall that we recently discussed a worrisome local privilege escalation vulnerability in the Windows user profile surface, which affected, or I should say unfortunately affects, all versions of Windows. This was that one that Abdulhamid Nasiri discovered and privately, responsibly, properly disclosed to Microsoft months ago. They then listed this as patched and fixed in August. But after he reverse engineered the change that Microsoft made to see what it was, he was kind of curious. Oh, cool. How'd they fix this? He discovered that the only thing fixed was that the simple proof of concept demo he'd provided to demonstrate the more severe underlying problem no longer worked. The underlying problem remained. So it wasn't fixed in August when it was supposed to be, nor in September or October or last Tuesday in November. On the one hand, if it's exploited, it allows an attacker to elevate themselves to full system, root privilege under Windows. But on the other hand, any such attacker would need to have knowledge of some second credential that would work on the same machine. The CERT CC guy, whose name escapes me, I talked about him before. He commented that would, and he correctly said, Will Dorman, that's his name. He correctly said that that meant this wouldn't be as widespread as many other things. Nassiri reminds us that any domain credential would be sufficient. So that does somewhat lower the bar for an attacker. I won't comment on the fact that when Bleeping Computer asked Microsoft about this still unresolved problem, Bleeping Computer were told that, quote, "We're aware of the issue and will take appropriate action to keep customers protected." Of course, okay, I said I wouldn't comment. But what I will comment on is that last Thursday, after seeing that Microsoft still hadn't fixed this for the 4th month in a row, the guys over at Zero Patch created one of their very cool little micropatches that, believe it or not, actually works and solves the problem. It can be applied to any Windows system needing interim protection until Windows gets it fixed. And of course, potentially on older systems that Windows will no longer fix. That's really sort of the niche that the Zero Patch guys have found is, you have to subscribe. You can sign up for free and get this for free, and it will be available until Microsoft fixes it for free. But you can also, if you're wanting to keep older systems alive for some reason that the Microsoft isn't fixing, these guys are still fixing all these things. So you can subscribe, and the Micropatch system automatically updates itself. And the patches are, wow, Leo, 23 bytes. So yeah. Anyway, they're available for 32 and 64-bit versions on any Windows 10 system with at least the October or the November updates in place. So again, let's hope that Microsoft gets this fixed in December. It'll be a nice Christmas present for Windows users. Until they do, this little micropatch is free. You do have to register, however. And I haven't taken any time to research in detail what it was that Nassiri found and what's going on. But the founder of Zero Patch did say that while this issue could, in theory, also impact earlier Windows versions, he said, quote, "The vulnerable code is different there, making the window for winning the race condition extremely narrow and probably unexploitable." Well, that's interesting, a race condition. We've, on this podcast, never had the occasion to discuss race conditions. But it's a common problem that can crop up anytime multiple things might be happening at once, where the precise sequence of them happening is important. A few weeks ago, I mentioned the counter timer in the original PC, which used what was known as a ripple counter. A ripple counter in digital logic is a series of individual toggling flip-flops connected in a chain. When a single toggling flip-flop's input goes to logic 1, nothing happens, except it registers it internally. But when that input drops back to logic 0, the flip-flop flips to its other on or off state, whichever the other one is. And if the output of that flip-flop is connected to the input of a next flip-flop, you start to obtain a binary counter, where the number of bits in the counter is the number of flip-flops in the chain. And I should confess, this is how I spent my youth, was like, drawing these things and drawing logic diagrams. And if anyone wants an interesting challenge, implement a toggling flip-flop with mechanical relays. Even if you don't actually build it, just draw them, because I did, and it's an interesting challenge. Anyway, the problem is flip-flops in the real world do not toggle instantly. They have what's known as a propagation delay, which means that their output changes just a little bit after their input goes to 0. The flip-flop's internal logic takes a bit of time to sort things out. This means that when the input at the front of this ripple counter goes from 1 to 0, which will start to update to the next count, the changes in the count might ripple down through the length of the counter. Okay, now let's say that you want to take a snapshot of the counter's current count, but you have no idea when that counter might be counting. This is where we get into a perfect example of a race condition. If we happen to take a snapshot of this binary ripple counter while that new count is rippling down the length of the counter due to the propagation delay in each of the counter's stages from one stage to the next, we'll obtain an erroneous reading due to a race condition which we've created between the counting event and our sampling of that counter. And, race conditions aren't just electronic. They can occur socially, too. They're a favorite vehicle of screenwriters who have one person racing to answer the phone before someone else gets the chance to do so to avoid some embarrassing outcome. A race condition in real life. In electronics and in software, these race conditions can be quite tricky to spot, and they've been known to introduce some of the hardest to find bugs there are. The reason may be that they may not occur predictably or even often, but just maddeningly. For example, the state of that ripple counter might be properly sampled thousands or hundreds of thousands of times before the sampling just happens to catch the counter in the process of rippling. The other maddening thing is that the act of observing the system might change it. For example, adding the tiny capacitance of a high-impedance oscilloscope probe when checking a high-frequency signal can change its timing just enough to prevent the problem from occurring while you're looking at it. And the same goes for debugging code. If you step through the troublesome area of some time-sensitive code, everything works while you're watching it. In fact, the problem only occurs, for example, on odd Tuesdays when the moon is full and the mailman is late. Otherwise, everything works fine. So our lesson here is the need, I guess first the appreciation of, or appreciation for, and then the need for true vigilance in any asynchronous multi-threaded application where more than one thread might share access to variables or objects. Always consider every implication of that very carefully. Always keep the possibility of these sorts of collisions front of mind and work very hard to never create such problems in the first place, because it's far better to prevent them than to have to go back and try to find those gremlins later. And as I was thinking about this, about the nature of the need to appreciate how big a problem this is, I sort of got into thinking about new coders who, anyone starting out at the beginning is going to begin their craft without any appreciation, because you can't have any in the beginning, for the subtleties and nuances of the way complex coding problems are best solved. And the word best is critical here. For newbies, it might at first seem that any solution to a problem with computers is as good as any other. After all, they're all solutions, aren't they? But with time and patience and lots of practice at coding, a coder gradually matures to learn that there are superior, more elegant, and more robust ways to think about, to frame, and then to solve a problem that may have many solutions. Most coding problems do have many solutions. Yet it's often the case that there really is one best way. And I think that the great joy of coding comes from the satisfaction of knowing that you have found the best solution. I'll often code something, and then I'll wonder, having done so, like I'm done, if I can't find a better solution. What I think happens is that the act of solving the problem the first time teaches us something about the problem that hadn't been initially appreciated. For example, I might have needed to add an awkward bit of code at the end to handle an edge case that I hadn't seen coming. But if I'd appreciated it at the start, as I do now at the end, might I have come up with an overall superior solution that inherently incorporated and didn't need that special case handling because it solved the problem the right way. So the point is, I may have just learned something about the problem that might now suggest an entirely different and superior approach. So what I often do is I'll leave what I wrote in place so I can go back to it if my intuition is wrong and I don't find a better way. I'll open up a big region of blank space in my editor and immediately tackle the same problem again, but this time starting with a deeper understanding of the problem I'm trying to solve. And for me, that's the continual fascination that I have with coding. It's why I enjoy it so much. Is 50 years later, 50 years after having started this, I'm still learning things. I'm tackling new problems. I'm taking all of this experience that I have, but I'm finding that I can still recast a first solution in something better the second time. And it's true. It will make no difference in what that chunk of code does, but it might make a difference in the way it does it. One solution may be aesthetically cleaner and superior to the other. And as utterly abstract as code can be, within its own little microcosm, it really is possible to create little works of art, little constructed gems. And I know that not everyone obtains fulfillment from building things. And not everyone is as curious as I am. And not everyone may have the luxury of taking the time to find that one best solution. If you are those things, then what I've just articulated makes all the sense to you in the world. And if you aren't those things, maybe you can now understand a little bit better those of us who are so weird in this particular way. And Leo, I have a feeling you may be one of them.
I'm in that former group, you bet. It's one of the things I go home and can't wait to get going on. Yeah. Yeah,
there just is something magical about it.
Race conditions are a big problem these days because we do concurrent programming so much. So, we have multiple processors. So it's not at all unusual to have multiple processes running at the same time. I have to say, though, I think some of it is because we made a big mistake many years ago going with imperative programming and programming with side effects. If you don't have side effects, you don't have problems with concurrency. You don't have dependencies. I guess sometimes you need side effects. For sure you do with I/O and so forth. But it seems to me that some of this comes from just a mistake made early on in how we write code. That's why I'm a fan of functional programming.
I think that's probably true. As you were suggesting that it was fundamental, I was thinking of, for example, I have some code which is manipulating a list. And where, like, I'm inserting an object into a list of objects. So I'm in the process of taking the pointer that points to the next one out and replacing it with a pointer that points to the new one, and then putting the pointer that was pointing to the last one at the end of the new one, inserting that into the list. Well, that's a fragile moment in time.
Exactly, right. And if another process is counting on that list, it's in an unknown state.
Yes. So if something else, another thread in the same process, or if it's a cross process, object which is available, it might go and take, it might get, swapped in, time sliced in, and be attempting to traverse that list while I'm in the process in a different thread of maintaining it.
Exactly.
And that's where that's another good example of like something that might work for 3 years and then just blow up. And it's like, what happened? And again, it's like just a moment in time where that race condition between two threads trying to simultaneous access. And so there are solutions in Windows. For example, it's called a critical section. You're able to request a critical section of code that no two threads are allowed to be in at the same time. And so in my own list management code, I grab a critical section, do the work, and then I exit the critical section.
You lock it in effect,
It's basically lock that little block of code.
That's why it's called a race, because the winner of the race can vary, and whoever wins will get a different result. Ideally, with code, you want the same inputs to produce the same outputs every single time.
Determinism.
It's determinist, and the degree that it's not is the degree. There are languages like Erlang that are designed to handle concurrency specifically for this. I think if Windows critical code worked better, we would see less of these bugs, but apparently either people aren't doing it or maybe it's sloppy coding. I don't think it's always sloppy coding. I think sometimes it's just you don't really realize the side effects that you're introducing.
Well, okay, to take Microsoft's side for a minute, can you imagine touching the code of Windows?
Right.
I mean, so,
it should all be critical section. The whole thing. Do not touch.
I mean, I have the advantage of being a one-person team who wrote everything that I'm doing and touching. So, if I make a mistake, it's mine. At the same time, I'm less likely to because it's mine. Nobody wrote anything that other than I did, and so I'm not looking at code thinking, okay, I think a long time ago, you and I talked about like some of the fundamental problems of coding. One of them is bad variable names, right? You name something and like badly, and then later you think that it's a good name, but if it's a bad name, it doesn't really describe what you think it does. And so that's one of the problems. And the other is like fuzzy definitions. If you're not really sure of what some code does, you're in trouble. Because the computer's not sure either, and if you're not sure, it's not going to be any more sure. And so there are again, as you spend time coding, you end up sort of with like your group of things that you learn to watch for. And I've learned the importance of being very careful about what I call things, because later I'll come back and I'll think they're exactly what I called them, and if I'm wrong, I get myself in trouble.
Yep. Well, and you also get some sympathy for people who make mistakes, because it's a hard and a high stakes practice. It's not easy.
Which is what makes it fun.
That's what makes it fun. Yeah.
So we did have last Tuesday, Patch Tuesday. We already know what Patch Tuesday didn't patch, right? It didn't patch Nasiri's problem. So what did it patch? It received fixes for a total of 55 flaws in Windows, 2 of which were zero-day vulnerabilities in Exchange and Excel, both under active exploitation in the wild. And by coincidence, the zero-day in Exchange had previously surfaced during that recent Tianfu hacking contest. 4 other vulnerabilities, although not being used in the wild, also qualify as 0 days because while they're not under active exploitation, they were first learned of through public disclosure without any available patches ready or even started. So of the total of 55, 6 are classified as critical, the other 49 as important. The exploitation breakdown is that 20 were elevation of privilege vulnerabilities. And we know now, even though they don't seem as scary as remote code, the bad guys want them because they can often get in as an unprivileged user, then elevating themselves to system is what they need to do in order to escape from the containment that the operating system provides. So 20 were elevation of privilege, 15 were remote code execution vulnerabilities, gulp, 10 information disclosure, 4 spoofing, 3 denial of service, basically means you can crash something, but that's about it, and then 2 were security feature bypasses. The Excel flaw, which was the other of the 0 days that wasn't the Tiana Fu discovery, was discovered by the Microsoft Threat Intelligence Center and has been actively used in malicious attacks. The 4 publicly disclosed vulnerabilities, those other 4 that technically are 0 days because they were posted publicly, have not been seen being exploited. 2 were Windows RDP, the remote desktop protocol information disclosures, and the other 2 were 3D viewer remote code execution vulnerabilities. So that's the good news. November did break something, but boy, you'd have to be deep into Azure authentication innards to understand what. After installing last Tuesday's updates, Microsoft said that users might experience authentication problems on domain controllers running Windows Server. Okay, that we understand. They explained, and I'm just going to quote them because I only have a vague idea of what this is. Well, maybe better than that, but still. Kerberos authentication, they wrote, will fail on Kerberos delegation scenarios that rely on the front-end service to retrieve a Kerberos ticket on behalf of a user to access a back-end service. Important Kerberos delegation scenarios where a Kerberos client provides the front-end service with an evidence ticket are not impacted. Oh, I guess that's good. Pure Azure Active Directory environments are also not impacted by the issue. And then, as if to clarify, on the Windows Health dashboard, Microsoft wrote, after installing the November security updates, you might have authentication failures on servers relating to Kerberos tickets acquired via S4U2 Self. The authentication failures are a result of Kerberos tickets acquired via S4U2 Self and used as evidence tickets for protocol transition to delegate to backend services which fail signature validation. So there. Whew. The good news is, whatever it was that broke, they fixed it yesterday, Monday, yesterday, with the release of an out-of-cycle update. So if anyone had updated last Tuesday and their use of Kerberos authentication to domain controllers had died, it's now fixed. As of Tuesday, you got to go get it, probably, so you can do so. On the Windows 11 front, Windows 11 received KB 572.15, a cumulative update to fix security vulnerabilities and bugs newly introduced, or at least occurring in previous versions. This update is mandatory because it contains security updates, performance improvements, and bug fixes for Windows 11 21H2. After installing the update, Windows 11 will have its build number changed to 22,000.318. So that's what you want to look for. There was, it turns out, a newly introduced problem with GDI Plus, which prevented the proper display of UI elements under Windows 11. That's fixed, and GDI Plus applications should now be working. And the update also fixes that mysterious, weird, built-in application signature certificate chain verification bug, which was preventing a subset of apps, remember, like not all, but a few, and some could be fixed, but some others couldn't, such as the snipping tool, from working in some instances for some users located on some planets. Now, everything is supposed to be working correctly once again for everyone after KB 572.15. Oh, and finally, Microsoft also stated that they made changes to the servicing stack to resolve bugs or issues preventing Windows updates from properly being installed. So now, presumably, Windows updates will no longer be prevented from being properly installed, to the tremendous relief of all concerned. And December promises to be Christmas for printing and more. It appears that the raft of continuous, embarrassing, and unrelenting problems with Windows that Windows has been experiencing has caught Microsoft's attention. Yay! Late last week, they released a new build for Windows 11 insiders in the beta and release preview channels, and it promises to have fixed a long list of issues impacting Windows 11. And Leo, I imagine you and Paul and Mary Jo will be talking about that tomorrow. Among the significant bugs addressed in this build, which is 22,000.346, are fixes for known issues preventing USB print devices with support for Internet Printing Protocol over USB from completing the installation and leading to some USB print installers reporting that they don't have a printer after the printer's plugged in. So there's that. The other issue fixed is one that we talked about a while ago, about several weeks ago, and that's where the three weird bugs RPC-S cannot support, error invalid level, and error invalid printer name. Those were occurring to some users who are trying to print remotely over network shared printers. Those are going to be fixed, have been fixed in this beta and release preview, and it's expected to roll out to all Windows 10 and 11 customers during the December 2021 Patch Tuesday. So, yes, everybody's going to get their printer things fixed finally. And, Leo, I need to get my parched throat fixed.
Okay.
And then we're going to talk about another nice ransomware bit of legal news.
So nice. I know what you're talking about. We talked about it on Sunday. Good news. Cool. Yeah, we'll get to that in a second. First, though, let's talk about why you still need a VPN. You need the VPN, Express VPN. They wanted me to say this. I'm embarrassed, but I'm going to say it anyway. Going online without ExpressVPN is like using the bathroom and not closing the door. You wouldn't do that, would you? That's why you need a VPN. People often say, well, I have nothing to hide. But even if you have nothing to hide, you still close the door, don't you? Internet service providers, for instance, we know every single website you visit. We also know now, thanks to it was funny, an anonymous research done by the, I think it was the FCC or the FTC. They took information from the top 5 internet service providers, but they didn't want to name names because they didn't want to embarrass anybody. But all of them are selling the information, collecting the information. They didn't want to embarrass anybody. Okay, fine. ISP is completely legal, can sell anything they find out about you to ad companies, to tech giants. So for a lot of people, just simple privacy is a great reason to use a VPN. A VPN, as you know, because you listen to this show, is an encrypted tunnel between you and the outside world, so that your internet service provider and whoever's sitting across from you at the coffee shop and all those people can't see what you're doing. But I would point out, of course, the people who can see what you're doing, the VPN provider, because they're running the server where you emerge into the outside world, they would have the same kind of access. That's why it's so important you go with ExpressVPN, because they absolutely do not log, they do not keep track of what you're doing, and they bend over backwards not to do it. They are regularly audited by independent third parties who say, yes, your privacy policy's absolutely correct, no logging, but they also have them vet their trusted server technology. I think this is so brilliant. When you press that big button on your ExpressVPN app, and there are apps for everything, iOS, Android, Mac, Windows, you can even put ExpressVPN on many routers, protect the whole household. When you start up that ExpressVPN server, it runs in RAM. They call it their trusted server technology. It's sandboxed. It cannot write to the drive. So even if some, I don't know, malicious employee or something wanted to log what you're doing, there's literally no way it can. It's running out of memory, can't write to the hard drive, and the minute you disconnect, it's gone. No logging. There's no trace that you ever existed. That's That's why it's so important you choose the right VPN provider. Low-cost and free VPN providers are strongly incented to monetize you in some other way. ExpressVPN, I think, is very affordable, very reasonable, about $7 a month, and you want to pay them. Here's another reason you want to pay them. You want to give them a reason to have a strong network, rotate their IP addresses regularly, and provide lots of bandwidth. And ExpressVPN does that. So much so that you can watch HD video on ExpressVPN without a hiccup, without buffering. That's really important because you might well want to use it to travel the world and view, let's say, Netflix in England or Japan while you're in the United States, or as I did when I was very frustrated. I'm in Mexico. I'm a Netflix user in the United States using my Netflix account. They said, you can't watch that here. It's like, what are you talking about? I'd even downloaded it. You can't watch that here. ExpressVPN to the rescue. That's why, by the way, it's important they rotate IP addresses as well. You don't want to always, you want to use different IP addresses. That's really the part of the privacy. You know, the IP address you emerge when you're using Google to do a search, they see your IP address, but it's not yours, it's ExpressVPN's. And it's good that they rotate those so they don't know anything about where you are, what you're doing. So secure. Just close and lock the bathroom door, as it were. #1 rated by CNET and TechRadar. Works on everything you've got. I often, when I turn it on, forget to turn it off because it's so fast. I forget I'm using it, which is not a bad thing. Leave it on. Secure your online activity. ExpressVPN.com/security now. ExpressVPN.com/security now. You'll get 3 months free with a 1-year contract. That's how you get it down to that very low price, $7 a month. 3 extra months free. ExpressVPN.com/security now. You're smart. I know you know all about VPNs. I know you know all about why to use them. I just want to put in a word for the best VPN provider out there, ExpressVPN. ExpressVPN.com/security now. And now back to Steve Arino. Steve?
So, the U.S. has detained a crypto exchange executive for helping Ryuk Ransomware, the Ryuk Ransomware gang, launder their profits. I'm not talking now any longer about the infinite series of ransomware attacks. You know, maybe if something of note that goes on to the popular news, we'll talk about if it's like huge, like Kaseya or one of the huge historical attacks. But I did want to keep everyone in the loop about news of the continuing U.S.-led pursuit of those who have been profiting from ransomware attacks, since we're seeing some evidence that it's having an effect. In this case, the suspect is named Denis Dubnikov. He was arrested 2 weeks ago on the 2nd of November while attempting to vacation in Mexico. Whoops. He was denied entry into the country pending an arrest warrant, and Mexican officials forwarded him to Amsterdam, where he was officially detained by Dutch police at the request of the FBI. Although arrests of crime suspects usually remain unreported until official charges are filed, in this case, the news of his arrest leaked through himself, who revealed his fate in an Instagram story he posted on his now-deleted account while he was in custody in Mexico, according to screenshots posted on Russian Telegram channels. The details providing his arrest had remained secret until just recently, with neither the Dutch police nor U.S. officials responding to multiple requests for comment. So there's still much that's not public. The Wall Street Journal obtained and reported upon an extradition request which revealed that Dubnikov stands accused of money laundering, according to court documents, around $400,000 in cryptocurrency assets tied to a Ryuk ransom payment passed through one of Dubnikov's accounts in 2018. And it's unclear whether the $400K passed through his personal account or through two cryptocurrency platforms, one called Crypto Coyote and the other is EggChange, which Dubnikov, who's a Moscow businessman, founded previously. A Bloomberg article published on November 3rd, the day after his arrest, named EggChange as one of the multiple shady cryptocurrency exchanges that are headquartered in a Moscow office building that's been tied to cybercrime money laundering. And the best news is that the arrest has triggered outrage within the Russian cryptocurrency community, and I think that's great. Several prominent figures are demanding an official response and condemnation of Dubnikov's arrest from the Russian government. Excuse me. I think it's great that something that happened 3 years ago is now being loudly dredged up and acted upon today, since you can just imagine all of the other crypto weenies out there starting to worry about what evidence from their own pasts can be reverse engineered out of the public cryptocurrency blockchains to irrefutable irrefutable evidence of their past misdeeds. As we noted last week, the money obtained from ransomware is seeming to be a little less free every day than it was before, when it was just a spree that all these guys were off on. Okay, so I propose the rhetorical question: how do you go about defrauding web-based advertisers? So you're a 41-year-old Russian national by the name of Alexander Zhukov. It occurs to you that advertisers pay websites who have their ads displayed to people who are presumably influenced to some degree by those ads, and who may even occasionally click on one to find out more. So, you establish thousands of entirely fake public websites hosted by legitimate cloud service providers and contract with those advertisers to have their ads shown on those sites' pages. And because video ads pay more, you focus upon having those hosted. But no one's going to those bogus sites because they have crappy synthetic content. So you create a wide-ranging network of bots called MethBot to visit those bogus pages instead from IP addresses scattered across the world as if they were actual people. You design the bots to poke around the various websites' pages to view, in quotes, those ads and videos, and to occasionally click on one to learn more. And the money starts rolling in. How much money? Is everyone sitting down? Between $3 and $5 million per day at its peak in 2016. But of course, it's fraud, since no one whose behavior might be influenced to purchase anything ever sees those ads for which advertisers are paying real money and money is being received. So something sets off some scam alarm somewhere, which causes the FBI, Google, and 20 other tech and security firms to begin probing and dismantling, unweaving Zhukov's operation. They soon discover a giant botnet running across infected devices and legitimate data centers spread around the world. And oddly, that botnet is visiting these bogus websites and clicking its links and ads. Shortly afterward, back in November of 2018, while traveling to Bulgaria, Zhukov is arrested on an FBI-issued warrant and is formally charged the next week. Tracked under the names 3VE, as in, Eve with the capital E backwards, Methbot, Boax, and Muref, Zhukov is believed to have run one of the largest ad fraud botnets ever created, generating, as I said, at one point in 2016, between $3 and $5 million in revenue per day. He hired programmers to help him build and manage his operation, and which he disguised under the guise of a legitimate advertising network named Media Methane. And according to prosecutors, Zukov referred to himself frequently as the king of fraud and his employees as my developers. But of course, instead of running an actual advertising company, prosecutors said that Zukov created thousands of fake websites where he loaded ads from legitimate publishers. These websites, they say, ran on more than 2,000 servers rented across data centers and had no real visitors. Instead, Zukov's team used automated tools to simulate real visitors. Prosecutors said Zukov often leased IP addresses for this activity, and in other cases, he hijacked legitimate IP addresses from their legitimate owners. But all that came to a just end last week when a judge sentenced Zukov, a U.S. judge, sentenced Zukov to 10 years in prison for running MethBot between 2014 and 2018. So, yeah, he probably should have quit while he was ahead. Certainly he was at some point far ahead, and then just gone off to an island somewhere. But then I guess you can't spend all that money if you're on an island. So I don't know what you do. You certainly don't want to travel. That seems to be when we get these guys. I've got some really fun closing the loop feedback from our listeners. Marcio wrote, he said, "Hello. This may seem like a strange request in 2021, and Leo, you'll remember this." He said, "But would you be able to offer some insight on the exact SCSI commands used by your click of death tool, Trouble in Paradise?" He says, "It might surprise you that anyone is still using zip drives in 2021, but SCSI iOmega zip drives are still used by people who collect vintage Apple Mac computers." He says, obviously, these computers can't run TIP. And for those who don't know, TIP stood for Trouble in Paradise, which was my click of death utility. I actually created it after the release of SpinRite 5, because SpinRite 5 was the first SpinRite that would run on iOmega zip and jazz drives, and those drives had a problem with their heads such that they would nick the edge of the soft, flexible media inside of those iOmega cartridges. So people were using SpinRite 5 to try to recover the data, but because it was like such a weird kind of one-off problem, it quickly occurred to me. At the moment I heard that, we were getting reports saying that SpinRite fixed the click of death, and it's like, the what? So I looked into the click of death, and I ended up writing a free utility which was much more problem specific. So, to where SpinRite was sort of a general solution, because what I learned was you could, the click of death could spread throughout a collection of zip drives. If you inserted a zip cartridge into a bad drive, it would nick the edge. But then if you then transported that cartridge, and of course transporting them was the whole point of having a cartridge, you then inserted this cartridge with the nicked Mylar into a good zip drive, it could damage the good zip drive in such a way that damaged zip drive would then damage other zip cartridges. It was literally a virus, like a mechanical virus, back in those days of iOmega zip drives. Anyway, he says, obviously these computers, meaning the Apple Macintoshes, can't run TIP. But I recently came across a PC SCSI adapter card at a surplus sale, and I decided to see if I could get TIP to run on a Windows PC. He says it turned out to be an ordeal due to the fact that Windows 98 simply doesn't run very well on newer hardware. But eventually, I got it all to work, and I'm very impressed, he wrote, with the tool, meaning TIP. He says, I was quickly able to troubleshoot my collection of zip media and drives, and that's, of course, why I created it. he says, anyhow, I would very much like to see if I could recreate a similar tool that runs natively on my vintage Macintosh computer so I can ditch the jerry-rigged Windows 98 PC and maybe help other Mac users who are also using zip drives. Could you provide any insight on the SCSI commands used? Signed, Marcio. And I zipped up, so to speak, my archive from whenever that was, and mailed it to him. I got an email from him yesterday saying that he had made great progress. He was, my assembly code is very easy to read. So although he's not an assembly code person, he is in the process of re-implementing TIP, Trouble in Paradise, on native Mac. And it turns out I'd forgotten to include an include file that had my equates for the SCSI commands that are unique to the iOmega, which I had somehow found reverse engineered, or I don't remember now what. And so I sent that to him this morning. But anyway, just very cool that a little bit of a blast from the past.
No kidding. Wow.
Yeah.
That's a lot of effort to go through to use your old zip drives, but okay.
Well, if you're a hobbyist and
it's fun.
And you're in love with old Macs.
Yeah, exactly.
Yeah. I got a neat tweet from a professor. His Twitter handle is prof_RAS6. Maybe that's, I don't know, the designation for the course he teaches. Anyway, and Robert, I don't know how to pronounce your last name. Skaya Babarassi. Sia Babarassi. Anyway, thank you for the tweet. And he tweeted, thanks for the dive into IRQs. I assigned that segment of the show as a reading, listening, watching assignment for my computer architecture class. Keep the deep dives coming. So, Robert, thank you for a little bit of positive feedback. And get a load of this, Leo. From a Bell Labs patent attorney, Stephen J. Phillips, whose email is still at bellsouth.net. The subject was Unix Programmer's Manual from Security Now 844. And remember that we put the cover of it as our picture of the week, and that it was early November, maybe it was the 3rd, was the 50th anniversary of at least that cover page. Anyway, Stephen wrote, the cover of the Unix manual brought back many memories for me. I was the Bell Labs patent attorney who consulted for the mathematics research department where Ken and Dennis worked.
Neat.
Yeah. He said, my bookshelf was lined with all the manuals as they issued. I spent many hours with the manuals and with Ken and Dennis trying to find out what made Unix tick. Wow. They were, and I, having worked with patent attorneys before, that is what a good patent attorney does. I mean, they're typically engineering trained, and so the inventor describes to the attorney, imparts the knowledge, explains what it is they invented, so that the attorney can properly create the legalese patent documents, which become indecipherable, unfortunately. But that's the nature of it. Anyway, he said they were very modest about their work and thought they hadn't really done anything new. For the record, I filed 2 patents now long expired. One for the set user ID bit, which allowed a non-admin process to have administrative rights for the duration of its existence. The second was for the block-oriented Unix file system structure. He said, I think our patent department was the first production user of Unix. We were looking for a word processing system, and they set us up with a PDP-11 doing text editing with Ed. Later, we built a homegrown filing system for our patent applications and called it the File Mechanization Project. Early days.
Wow.
We had fun after Unix became famous when we were called into AT&T corporate headquarters to explain to the executive suite what in the world Bell Labs was doing creating software when telephones were our real business.
Wow.
So
really
Stephen,
interesting. Yeah.
Thanks for the very cool
yeah.
blast from the past.
Yeah.
Ben Clapp tweeted, "Hey Steve, love the show. FYI, in case no other listeners have shared, Visual Studio Code is now rendering the Unicode directional formatting characters by default. I hope more IDEs do this." And Leo, this is the episode that you missed, but it's great to see this happening. I mentioned last week that GitHub was now going to be highlighting and spotting this. This is a perfect example I have in the show notes where you can see an invocation of a function transfer balance where it shows the from, to, and amount, and it shows 5, 6, 7, 8, 1, 2, 3, 4, and 6, 7, 7, 6, respectively, as from, to, and amount. But the actual code down below, because there are hidden direction reversal Unicode characters, shows that the code that the system would process is different.
It's backwards. It's the opposite. Holy cow.
Exactly.
Which is a lot more money, I presume.
Exactly.
Holy
it's certainly not what was intended, because that Unicode 202E is the right to left override, and the Unicode 202 Charlie is the directional pop, which pops the effect of the override. So Unicode itself turns out to be a stacked-based interpreter. And this is what bad guys have actually gotten themselves up. I mean, some instances of this have been found in public source repositories. So it has actually happened.
Wow. Huh.
Very, very cool.
Clever. Yeah.
Yeah. And a little bit of an update on SpinRite, which continues to. I'm the proud father. I'm nearly finished. No, it's turning out so nicely. I'm nearly finished with the 6th development release. The screenshot I've got in the show notes shows SpinRite's updated drive selection pane on the left, which now displays what most SpinRite users actually want to know: the estimated time to scan each of the drives upon which SpinRite's benchmark has been run on. And so you can see under this scan time column is the number of minutes, or in a couple cases hours, for really large multi-terabyte drives, how long SpinRite will take. And the first line item, which I'm showing, shows that the performance of a 250 gigabyte Crucial SATA 3 SSD under SpinRite is 573 megabytes per second. Okay, now SATA 3 has a line rate, like a physical electrical bit rate of 6 gigabits per second. But SATA is a serial self-clocking protocol which requires some encoding of the user's raw data. For example, if you were to send all zeros, which meant no bit transitions, then the self-clocking would fail, because there'd be no way for the other end to keep track of precisely, 6 gigabits. I didn't do the math, but if you, that's 6 times 10 to the, mega 6 giga is 9, right? 6 times 10 to the 9, you flip that over, that's how short the bit window is. And you have to account for jitter and so forth in the line. Anyway, the point is that it's necessary to encode the actual data being sent into something that's guaranteed to have a minimal number of bit events, no matter what data is being sent. Consequently, the 8 bits of data, every 8 bits of data is encoded into 10 bit symbols for transit over the wire. Therefore, that raw 6 gigabits per second on the wire translates to exactly, since every byte turns into 10 bits, 6 gigabits turns into 600 megabytes per second of possible data, 600 megabytes per second. But a SATA serial link doesn't only carry the user's data, right? I mean, there's no other channel. So, all of the links, non-data control signaling also shares the same wire. So SpinRite's new hardware AHCI drivers are achieving, on that crucial 250 gig SSD, 573 megabytes per second out of you can't get it any faster. The theoretical byte transfer is 600 megabytes. We're at 573, which is 95.5% of that 600 megabytes per second. So we're only losing 4.5% to the control signaling overhead, and there's no way to squeeze that down any further. And given that most SATA 3 benchmarks you'll find show between 550 and 560 megabytes per second, I'm very pleased that SpinRite is achieving a sustained rate of 573 because it's literally, it cannot go, and SATA 3 cannot go any faster. Those little SATA 3 cables are smoking. Since I think anyone who's interested in SpinRite might be curious to know more, I created a 4-page PDF which shows a bunch of SpinRite's new screens along with some editorial commentary about what the various drives and controllers are. It's our shortcut for the week. So this episode is 845. So the shortcut is grc.sc/845. For anyone who is interested. And anyway, just a nice little checkpoint on where we are. I'm just about finished with, as I said, this 6th development release. I can't wait to get it into the hands of its testers. It's performing better for me than anything has previously. And in fact, this one incorporates that whole new poly IRQ solution, which I implemented after we learned conclusively that there was a BIOS that was lying about which IRQ line its controller hardware was using. So I thought, okay, that means I can't care. So now SpinRite doesn't, and I think that's going to make a big boost. I'll certainly have news about that next week because I'm sure I'm only a few days away from getting it into the hands of our testers. And Leo, the return of Rowhammer, badder than ever before.
Badder than ever.
Badder than ever.
Our show today brought to you by Better Than Ever Stripe. I don't have to tell you about Stripe. Leaders of adaptive businesses choose Stripe as their payments platform because with Stripe, businesses can easily optimize their payments infrastructure, simplify their expansion plans, and create new revenue streams, all to help them grow and initiate change rather than having to react to it. That's just a few of the reasons why businesses like Shopify and Twilio and Postmates, and a little business I think called TWiT, looks to Stripe to power their global payments. Stripe helped Postmates increase their authorization rates. This is actually, and I didn't know anything about this until I started getting into it, but this is a big deal if you have online payments. Postmates use Stripe to stop more fraudulent transactions from processing, thereby increasing their authorization rates, simultaneously allowing more legitimate transactions to go ahead. How much of a difference does that make? About $70 million in additional revenue for Postmates in a 12-month period. That's how important this stuff is. And of course, from the end user's point of view, Stripe is easy to use. From your point of view, it's easy to use. Once you integrate it, their single platform and world-class stocks allow businesses to experiment, to scale and grow revenue. Stripe is, of course, world-class. They process billions of dollars every year. And for every size of business, from pre-seed startups to Fortune 500 companies, and they're always improving it. Hundreds of improvements every year. New features to help stay ahead of the industry shifts. And talk about reliability. 5 nines API uptime, 99.999% API uptime. They do more than 250 million API requests every day. When we launched Club TWiT, we chose Stripe as our payment platform, and I'll tell you, we love it for a variety of reasons. One is we're a global enterprise. Stripe allows us to accept 135 plus different currencies and payment methods. That's nice. It's completely seamless in accepting payments and issuing refunds. We couldn't be happier. We're also able to focus on the business of producing our shows and let Stripe, and this is what you want in your business too, handle the business of payments and money movement. We don't have to think about it. It just happens. Stripe is also a great citizen of our planet Earth. With Stripe Climate, there's a little switch you can turn on in your Stripe account. You can direct a fraction of your revenue to help scale emerging carbon removal technologies. Just a couple of clicks and you're doing it. Please do. It's a great idea. Stripe Climate. So whether you're an online or in-person retailer, software platform, marketplace, or, subscriptions podcast business, visit Stripe.com to learn more about how Stripe can support your business today. We're big fans. Stripe, S-T-R-I-P-E, Stripe.com. Learn more and get started today. We use it, so should you. Stripe.com. And now I hand you over to the blacksmith himself, Mr. Steve Gibson.
Okay, so we have the return of Rowhammer. Probably the biggest and most significant security news of the week appeared yesterday with a report published by the ComSec Computer Security Group. As I noted at the top of the show, we've spoken of the work of these guys before, but only identifying them as being a team at ETH Zurich. ComSec is the computer security group of the Department of Information Technology and Electrical Engineering. Their primary research goal is the construction of reliable and secure computing systems, so their research often touches on all layers of the computing stack, from software all the way down to hardware. They explain that they use novel analysis techniques to better, certainly in this case, to better understand the attack surface of modern systems and, when appropriate, build systems that can withstand different classes of attack. Their just published work is their design of Blacksmith, which represents the maturation of Rowhammer attacks. Now, to briefly remind everyone, Rowhammer refers to a broad class of so-called bit-flipping attacks upon the unfortunately fundamentally flaky nature of today's dynamic RAM memories. You know, the big high-density DRAMs that we're all dependent upon. I'll crib from Wikipedia since it's perfectly summarized there. Wikipedia says, Rowhammer is a security exploit that takes advantage of an unintended and undesirable side effect in dynamic random access memory, DRAM, in which memory cells interact electrically between themselves by leaking their charges, possibly changing the contents of nearby memory rows that were not addressed in the original memory access. This circumvention of the isolation between DRAM memory cells results from the high cell density in modern DRAM and can be triggered by specially crafted memory access patterns that rapidly activate the same memory rows numerous times. Now, we've been tracking this, the problem, since its first appearance, believe it or not, 7 years ago in 2014. And it's been a constant background issue for the industry, which never quite goes away. The same research group developed their Smash attack at one point, which was a JavaScript-based attack that gives the attacker an arbitrary read and write primitive in a web browser. Then, Leo, you'll remember, there was Drammer, which was the deterministic Rowhammer attack on mobile platforms, and we had fun with the Flip Feng Shui, which was hammering a needle in the software stack. And then there was an over-the-network Throwhammer due to its distance. And now we have Blacksmith. In other words, this has been fodder for lots of research. And again, as I said, we never really get this thing resolved. The reason we cannot seem to shake this is that the problem the first Rowhammer research revealed is not, as we say, a bug of DRAM. It's unfortunately an unwanted feature. It cannot truly be fixed because it has always been an essential truth incorporated into the way DRAM operates. And in that respect, it's a little bit like all of the problems we had with Spectrum Meltdown and the optimizations that Intel had incorporated into their chips. It's like it's in there. It's kind of baked, and we're hoping that it doesn't get it really bad. Now, historically, there have been other noisy and usage pattern sensitive mass storage systems. Those real old-timers among us will remember that core memory technology, which was used in the early mainframe and mini-computers of the 1960s and 70s, were similarly sensitive to access patterns with adjacent bits. Memory diagnostics were run with things like so-called checkerboard patterns in an attempt to store and retrieve worst-case data patterns. If your core memory back then was acting up, you wanted to determine that while running a diagnostic and not while processing real-world data that might trip the same flaw by mistake. And even today, the venerable MemTest 86, now MemTest 86 Plus, which is over at memtest.org, remains a viable and worthwhile test of a system's memory. I've had occasion to run it through the years when something seems a bit flaky and I want to rule out a problem with DRAM. DRAM is big. Processor access to DRAM is much slower, and something like MemTest must bypass the cache, the level 1, level 2, and level 3 cache. So it's surprising how slowly it runs when you're actually testing DRAM directly, but that's what a good memory test has to do. So it's the kind of thing you run overnight. And in the case of DRAM's inherent vulnerability to row hammer attacks, the best we can do is attempt to minimize and mitigate what is unfortunately a pervasive threat. We have been told with a great deal of hope and some expectation that the newest generations of DRAM, DDR4, were going to resolve this problem by incorporating specific anti-row hammer mitigations. So, how'd that work out? The short and depressing answer is that the DDR4 memory protections have been broken wide open by Blacksmith. The ComSec guys explain. They said, quote, "We demonstrate that it is possible to trigger row hammer bit flips on all DRAM devices today with little effort, despite deployed mitigations on commodity off-the-shelf systems. This result has a significant impact on the system's security, as DRAM devices in the wild cannot easily be fixed, and previous work showed real-world row hammer attacks are practical, for example, in the browser using JavaScript, that was their own work, on smartphones, across VMs in the cloud, and even over the net. Row hammer, they say, is a vulnerability caused by leaking charges in DRAM cells that enables attackers to induce bit flips in DRAM memory. To stop row hammer, DRAM implements a mitigation known as TRR, Target Row Refresh. Our previous work showed that the new n-sided patterns can still trigger bit flips on 31% of today's PC DDR4 devices. We propose a new, highly effective approach for crafting non-uniform, frequency-based row hammer access patterns that can bypass TRR from standard PCs. We implement these patterns in our row hammer fuzzer named Blacksmith and show that it can bypass target row refresh mitigations on 100% of the PC DDR4 DRAM devices in our test pool. They had 40. Further, our work provides new insights on the deployed mitigations. So, how'd they do it? They conducted a series of experiments, beginning with the observation that all of the previously used rowhammer attacks used uniform patterns, such as single-sided, double-sided, and n-sided attacks. The patterns were uniform in both pattern and in number. So this made them curious about DRAM's sensitivity to non-uniform attack patterns. Since the search space of non-uniform attack patterns is huge, they conducted a series of experiments to determine the structure of patterns that effectively bypass the target row refresh mitigations. And they discovered that the order, regularity, and intensity of accessing aggressor rows is the term now of art in rowhammer attacks, of rows that you read in order to cause your target row to get itself confused. So again, the order, regularity, and intensity of accessing aggressor rows in non-uniform patterns form an essential component of successful attacks. They noted that their observations matched well-known parameters within the frequency domain, namely frequency, phase, and amplitude. So they used those frequency domain patterns to design frequency-based rowhammer patterns that can effectively explore the space of non-uniform attack patterns. They implemented these patterns in their black box fuzzer, which they named Blacksmith. Blacksmith is able to determine suitable parameter values for any specific targeted device. So essentially, it uses fuzz-based attacks to learn about a specific DRAM's sensitivities. Okay, so how powerful and practical are the resulting attacks? They wrote, our evaluation, for our evaluation, we considered a test pool of 40 DDR4 devices covering 3 major manufacturers, Samsung, Micron, and SK Hynix, including 4 devices that did not report their manufacturer. We let our Blacksmith fuzzer run for 12 hours to assess its capability to find effective patterns. Thereafter, we swept the best pattern based on the number of total bit flips triggered over a contiguous memory area of 256 megabytes and reported the number of bit flips caused. The results were that our Blacksmith fuzzer is able to trigger bit flips on all 40 DRAM devices with a large number of bit flips, especially on devices of manufacturers which they anonymized as A and D from their research. We also evaluated the exploitability of these bit flips based on 3 attacks from previous work. An attack targeting the page frame number of a page table entry to pivot it to an attacker-controlled page table page. Now, that's one of the things we talked about in the past, remember, that if you could arrange to flip a single control bit on a page table from read-only to read-write, the jig's up. You know, the OS absolutely depends upon its page tables being protected. All you have to do is flip that bit and you have, you know, a massive attack. Also, they did an attack on the RSA 2048 public key that allows recovering the associated private key to authenticate an SSH host successfully, and an attack on the password verification logic of the sudoers.so library that enables gaining root privileges. All attacks were successful. They said, our work confirms that the DRAM vendors' claims about rowhammer protections are false and lure you into a false sense of security. All currently deployed mitigations are insufficient to fully protect against rowhammer attacks. Our novel patterns show that attackers can more easily exploit systems than was previously known. Okay, so their work has been assigned a CVE number, 2021-42114, and their paper, titled Blacksmith, Scalable Row Hammering in the Frequency Domain, will be presented during the 43rd IEEE Symposium on Security and Privacy. I have a link to their 19-page PDF research in the show notes for anyone who's interested, and they assembled an FAQ to ask and answer some top-of-mind questions. First, they asked, are there any DIMMs that are safe? They answer, we did not find any DIMMs that are completely safe. According to our data, some DIMMs are more dim. Some DIMMs are more vulnerable to our new row hammer patterns than others. Which implications do these new results have, I meant what implications do these new results have for me? And answer, triggering bit flips has become more easy on current DDR4 devices, which facilitates attacks. As DRAM devices in the wild cannot be updated, they will remain vulnerable for their service life. How can I check whether my DRAM is vulnerable? And this is interesting. The code for our Blacksmith row hammer fuzzer, which you can use to assess your DRAM device for bit flips, is available on GitHub. We also have an early FPGA version of Blacksmith, and we're working with Google to fully integrate it into an open source FPGA row hammer testing platform. That would be, several things cool there. First of all, anybody who wants to compile their row hammer fuzzer from GitHub can, and I will make the following offer. If anyone does, I'd like to know. I imagine you have to boot a system. I don't know what OS platform this thing's hosted on, because you'd want access to all of memory, but maybe they just satisfy themselves with running within, like allocating as much memory as they can and then pounding away on that. We'll see. The FPGA is interesting. That's a field programmable gate array, which means that it would be possible to create a piece of hardware into which you plug a questionable DRAM or any DRAM and press a button, and it goes to town fuzzing that DRAM in order to determine how vulnerable it is. Because there wasn't room for it in the show notes, but in their paper, they show their results across all 40 of their tested DRAMs, their DDR4 DRAMs, and it is the case that some had 4 bit flips, some had 400 million bit flips. In other words, there's a massive range of vulnerability to, obviously by manufacturer. Some manufacturers are having a higher bit flip rate than others, and also by DRAMs within a manufacturer, probably within a production batch. I mean, it's based on the marginalness of the actual silicon that these things are being printed onto. So I expect we're going to be hearing a little bit more about all this in the future. They ask, why hasn't JDEC fixed this issue yet? And they answer, a very good question. By now, we know, thanks to a better understanding, that solving row hammer is hard, but not impossible. We believe that there's a lot of bureaucracy involved inside JDEC that makes it very difficult. So, what if I have ECC-capable DIMMs? They answer, previous work showed that due to the large number of bit flips in current DDR4 devices, error correction will not provide complete selection against row hammer, but makes exploitation more difficult. And we did talk about that in the past, about the fact that you can bypass ECC by flipping a pair of bits rather than just one. They ask, what if my system runs with double refresh rate? They answer, besides an increased performance overhead and power consumption, previous work showed that doubling the refresh rate is a weak solution, not providing complete protection. They ask, why did you anonymize the name of the memory vendors? They said, we were forced to anonymize the DRAM vendors for our evaluation. If you are a researcher, please get in touch with us to receive more information. And finally, does Blacksmith work on DIMMs from other vendors? And they answer, according to statistics, the 3 DRAM chip manufacturers considered by us cover 94% of the DRAM market. However, we have tested Blacksmith on 3 DRAM devices from another vendor, and we could successfully trigger bit flips on these devices as well. So, this is not a story that has a happy ending or anything that we can update or patch or even hope for a patch in December. But it is critically important research for the industry. We all understand that today's security is porous, and we've never before been in a climate that's placing more pressure against our porous security boundaries than we are now. Bad guys are going to weaponize this research. That's clear. That's what they do. The problem, as has been observed, is that the world is already filled with DDR3, very vulnerable, and DDR4, still vulnerable, DRAM, all of which has now been shown to be very much more vulnerable than we believed before, and indeed to be practically vulnerable. That is, these are not theoretical. You can actually get up to some mischief with this. So the consequences of these bit-flipping attacks are serious. And as I said, there's been talk of an FPGA, which would be very cool because it would create, some hardware. But we know that there is a range of existing vulnerability from not so much to very. So, if there was a practical solution for qualifying the vulnerability of DRAM, that's certainly not going to make the vendors very happy. But you can imagine people, over-ordering, get 12 when you need 8, and select the 8 that are the least vulnerable and return the 12 because you didn't mean to order them in the first place. Return the 4, I meant, that are the most vulnerable. Of course, that then creates a pool of higher vulnerability DRAM that other people will be purchasing. So there's no good solution. Anyway, I think I'm curious enough to go take a little peek over in GitHub and see what's there. I'm not going to spend any time on it. SpinRite is all I'm doing right now, folks. But anyway, we got a lot of other listeners who are obviously very talented and interested in security. So if any one of our listeners does something with their research on GitHub, definitely let me know. I'd like to know, and I'd like to share your results with everybody else here.
Yeah, cool. I guess I don't know if it's typical by brand or if it's just that particular stick. I don't know. We'll see. Maybe a lot of people do it. Yeah. That concludes this edition, the Blacksmith edition of Security Now. Steve Gibson is at grc.com. That's the place to go for the world's finest mass storage, maintenance, and recovery utility. SpinRite, currently 6.0. 6.1 is coming. And you can participate in the development, plus get a free copy when the upgrade comes. If you go right now and buy 6.0 at grc.com. You'll also find there 16 kilobit audio for this show. If you are bandwidth impaired, of course, the full 64 kilobit as well. And it's the only place you can get the transcripts, which Steve commissions. And thank you for doing that. And thanks to Elaine Ferris for writing those. grc.com. Lots of other free stuff there. It's well worth checking out. And you can leave him feedback there at grc.com/feedback. Steve's DMs are also open on Twitter at SGGRC. So you can ask a question or send him a picture of the week there. We'd have a copy of the show, both audio and video, at our website, twit.tv/SN. We also have a YouTube channel dedicated to Security Now, so you can watch it there. Of course, you can subscribe in your favorite podcast client. That way you'll get it automatically the minute it's available. Those who want to watch us do it live, and there are people, believe it or not, I'm talking to you, Grayson, who are listening live. And they do that at twit.tv/live. There's audio and video there. Chat live at irc.twit.tv or in our Club Twit Discord. All of that is just for you. We thank you so much to our Club Twit members for making it possible, and, of course, to all of you for listening. And most importantly, thanks to Steve Gibson. Have a great week, Steve. We'll see you next time on Security Now.
Thanks, buddy.
Have you ever read a tech news story and thought to yourself, man, I would love to talk to the person who wrote this to find out more information? Well, that's exactly what Micah Sargent and I, Jason Howell, do each and every week on Tech News Weekly. We read the stories that matter to us, we reach out to the people making a break in the tech news, and we invite them on to tell their story. And you can find it at twit.tv. Look for Tech News Weekly every Thursday.
Security Now.